Hello, I'm Jason with scienceandmath.com. In today's experiment, we're going to make what we call a density tower, or a tower of density. And what that means is we're going to take various liquids that you probably have around the house or that you can easily find at the grocery store, and we're going to put them in a container and watch that each of these layers are going to basically float on top of the layer below it and make a nice colorful tower that we can then use to kind of talk about things like density and buoyancy and floating in terms of what it means in science. So let's go ahead and do that. What you need for this experiment is, like I said, things that you'll probably have around your house. Get some vegetable oil, canola oil, corn oil works fine. You will need a glass of some kind. In this case, I've got a glass jar, but a regular old glass will work fine. I've got some rubbing alcohol here. It's just regular rubbing alcohol that you get from the drugstore. Some water. I've got some Karo syrup here that you can get from the grocery store. Some regular old honey, again, just from the grocery store. Some red food coloring, and in here is just various different things that you find around the house. We're going to try to float and sink these things. I've got a dye here. I've got a pecan here, I've got a rock, I've got a few things in there. So this is sort of like whatever you can find around the house. So all of these liquids that we've listed here, they all have different densities. And density basically lets you know if something is going to float or sink. So if we're talking about water, which is usually, when we talk about floating, we're thinking usually in terms of water. If something floats or sinks in water, all depends on its density, the material's density compared to the density of water. And in layman's terms, that basically means, is it heavier than water or is it lighter than water? So when we're talking about if a rock is going to float or not in terms of water, we're talking about how heavy is that rock compared to the same amount of water. If it's heavier than the equivalent amount of water that the rock occupies, then it's going to sink. If it's a piece of styrofoam, for instance, we know that that floats in water, then if the weight of that styrofoam is less than the same amount or same volume of water that it occupies, if it's lighter, then it's going to go ahead and float to the top. So that's what we talk about in terms of water, but that idea extends to any liquid, whether it's canola oil or honey or Karo syrup or whatever. So we're going to explore that here. Let me kind of move most of my materials over to the right-hand side, and we're going to we always do this. We wear our safety glasses and we're going to be safe about things. And what we're going to do before we do anything first is we're going to put our plate here that we're going to work on, because we're going to be dealing with liquids, so we just want to make sure we have something just to catch any spills. Now, one of the liquids here, notice some of these liquids are clear and some of them aren't. For instance, rubbing alcohol. It looks a lot like water, but you know it's not water, it's alcohol. So we want to make it visible. We want to be able to see it if it floats or sinks. So what we're going to do before I do anything else is just put some alcohol into the cup here. And I'm going to put some red food coloring in it. The only reason I'm putting the food coloring in the alcohol is just so we can see it. So we'll go ahead and be generous. We want it to show up. So we'll put, probably 3 or 4 drops, something of that nature on top of, on there. And we'll just kind of stir it up. So now we have a nice crimson color there. So this is not Kool-Aid though, this is alcohol. And we'll see how that reacts, or if it floats or if it sinks on top of the other liquid layers. Now, of everything here, honey actually is the most dense. And that means that once everything is all said and done, honey is going to be at the very bottom. And kind of think about it, if you've ever held a jug of honey and even compared it to like a jug of water of the same size, the honey is heavier. So that's actually going to go on the bottom. So what you want to do is literally just squeeze it on in there. And the thickness of your layers really is up to you. It doesn't really matter. But you want to have them thick enough so that you can see the end result. Something like that. You can see very clearly that you've got a nice layer of honey there, maybe a little bit more, because this is the bottom layer and I want to make sure you can see everything. So we'll go a little bit more and give ourselves some honey. Now, of everything else we have, the next lower density substance that we have is actually this Karo syrup. It kind of has the consistency of honey. It's kind of thick, like you can see it kind of coating the jar here as I slosh it around. And as things go, if you were to measure the density of this, the highest density would be the honey, the next guy on the list would be the Karo syrup. Now when you're putting the next layers on, you need to kind of do it carefully. Don't just dump it in there super fast, because even though everything's going to balance out in the end and start floating appropriately, if you kind of do it too fast, you might wait a long time for it to settle. So for the Karo syrup, we want to go ahead and just very gently and gingerly kind of add that in there. So you can see it's kind of clear, and it just goes in, and you'll start to see it float on top of the honey layer. Now you have to look carefully though, because the honey is already kind of transparent. It's got an amber color to it. The Karo syrup, notice I got light Karo syrup. When you buy Karo syrup, you can buy it as a light version or as a dark version. And in order to be able to see it easily, you really want to try to get the light version of the Karo syrup. So let me just do a little bit more here. I think we've almost got enough Karo syrup in the container. That's about right. All right, so there's Karo syrup. Okay, now if you look carefully, what we have already, the Karo syrup is floating on top of the honey. Now what that proves to you is that it's less dense than honey. If we want to find out if something floats or sinks, we compare it to what we're pouring it on top of. So here we have honey at the bottom. Believe me, if these two things were both water or both of the same density, they would just mix into one substance. But since this guy has a nice distinguished layer on top, then it basically proves that it's floating on top and it has a less density than the honey that's below it. Now the next thing we want to do is go and work with regular old water, because as we go in order, this is going to have a slightly lower density than the Karo syrup, so it's going to float on that Karo syrup. But because the Karo syrup is clear and the water is also clear, if we pour it in there, it's going to be really hard to see the layers. So what we're going to do is get our water here in our little measuring cup, and let's put some food coloring in that just so we can see the different layers. So I'm going to choose green here, just so I don't have anything else green in this experiment. I'm going to put a couple of drops to make it nice and vibrant. Okay, and we'll just stir that around. So we have a nice deep green color, which will show up nicely against it. Now actually I don't want it to be quite that green. I want to be able to see through it nicely, so I'm going to add a little bit of additional water to it just to lighten that color up more than anything else. I'm not going to use all this water. I'm just doing that to make the green color a little bit lighter. All right, and so what we're going to do is pour it in. Now again, you got to be careful. You don't want to dump it in there, because then it'll start mixing. It'll take a long time to settle out. So actually, if you have like a turkey baster or something where you can kind of like gently put it in, that would be even better. But in this case, we'll just gently pour it on top. And you should be able to see it start to form a layer right on top of that clear Karo syrup. And notice why we colored it green now, so we can actually see it very clearly. All right, that's good. So now we have three nice layers. We have our honey, we have our Karo syrup, and notice this nice green water that we've colored is floating right on top of the Karo syrup. If you gently tilt your bottle, you'll see all the layers move. So everything's floating on top. They're not mixing together. All right, next, we all know that oil likes to float on top of water. And so this is water, and here's oil. I'm not going to color the oil because we've colored the water. Everything will stand out. And again, we want to be careful. We don't want to go nuts. We want to just sort of gently pour it in there, because we don't want too many bubbles to form. It's kind of inevitable whenever you deal with oil and water, you're going to get bubbling. But they will eventually go away. If you set this on the counter for an hour or so, then all of these bubbles will completely disappear. In fact, even over the next few minutes, they'll sort of disappear. So let's go ahead and put that in there. I think that's a pretty good layer, maybe a little bit more, like this. Okay, so what we've shown here is oil is less dense than water because it's floating. That means for the same amount of the stuff, for the same volume of water, the oil actually weighs less, so that's why it floats. Now what we want to do next is we want to pour our alcohol, which is our rubbing alcohol, in there, and we're going to transfer it to a measuring cup so that we can have a nice pour spout and get it in there without getting it all over everything. Now what you can see after we poured the alcohol in is it kind of dove down deep, and then it started to form these bubbles, and notice how it started to come back to the top. So you can clearly see that we have a red layer on the top. That's the alcohol that we colored red. So our 5 layers are, in order of increasing density, we have an alcohol layer, we have an oil layer, and then we have the green water layer, and then we have Karo syrup, and then we have honey. And notice the boundaries are very, very distinct and very, differentiated from one another. Now notice, again, we have bubbles all throughout this container. If you were to let this sit on the counter for 30 or 40 minutes, these bubbles would basically all bubble up into their appropriate place, and they would basically disappear. But what it shows you is this is your tower of density. It shows you that things can float on top of one another depending on their densities. And you kind of have intuitive understanding of that. Alcohol is real thin. It evaporates quickly, and it just doesn't feel like there's much there. And then you have oil, which is a little bit thicker and heavier. And then you have water, which is even heavier. And then you have your syrups, like your Karo syrup and your honey. Now, if you notice carefully, what we see has happened is we have a nice red layer of alcohol here, but we also have kind of some of this red that's kind of bled down here near our water layer. Well, what's happened there is, what do you think food coloring is made of? Food coloring is some kind of coloring, and it's mixed with water. When you squirt the food coloring out, it's mostly water. So the water in there, some of it has descended down and kind of mixed in with our water layer. So really, in our tower of density, we have honey, we have Karo syrup, and our water layer is right here. It's got the green stuff, and it's got a little bit of red as well, because that's some of the food coloring made its way down there. And then we have our oil, and then we have our red alcohol here as well. If we would have just put the alcohol in without it being red, without coloring it first, it would be a real difficult time to see that. All right, now we get to have a little bit of fun. Let's go ahead and put this on the white sheet of paper, and let's see if we can figure out what's going to happen to some of these things. So here is a rock. I imagine a rock's going to sink, but the question is, where is the rock going to stop? What layer is it going to stop at? Is it going to go all the way down to the water and kind of just go below that? Is it going to go all the way to the bottom? Or is it just going to stop somewhere in the middle? Let's find out. So if we gently drop this rock in, of course it's going to mix everything up along the way. Where is it going to stop? It made it through the water layer, and it's gone into the honey layer. It looks like it's going to the very bottom. Okay, so this is our water layer here, which is kind of the greenish with this blackish stuff here. That's our water layer. So it looks like it made it all the way to the bottom. What does that mean? That means that rock, the density of that rock is greater than honey. It means if you look at the same amount of honey that was occupied by the space of that rock and compare them together, the rock weighs more. And that's why the rock goes down there. And it kind of mixes things up along the way. Let's take a die. This is a regular old die that you get out of a board game. Let's gently drop it in and see where it goes. The dye goes through the alcohol, it goes through the oil, it goes through the water, it's into the Karo syrup, and let's just see if it settles on top of the honey or if it continues down to fall on top of the rock. And it looks like it's going into the honey on its way to the bottom of the container. Okay, so it looks like it's more dense than the honey. It looks like it's kind of wanting to stop, but it's going a little bit deeper. What about something like this pecan? This is something that everybody has handy. We'll drop pecan in. It's heavier than the alcohol, heavier than the oil, but as soon as the pecan gets to the water layer, which is this kind of blackish layer right here with the food coloring, it actually floats there. So that means basically whatever you drop in here, it's going to stop right at the point where it hits the liquid that it floats on top of. Pecans float on water because they're slightly less dense than water, and it sinks through these other layers in order to get there. Okay? What else do we have? Here is a piece of wood. Let's see what a piece of wood does. Piece of wood actually stays right in the top of the container. It doesn't actually go anywhere, it just stays right on top. So this wood is actually less dense than even the alcohol. Not even dense enough to go down any farther. Let's try this bottle cap. Actually, let's try this plastic cap. Just drop that in there and see where that goes. And I'll use my screw to actually kind of push it down, give it a little head start. And it looks like the bottle cap sinks past the alcohol layer but starts to float in the oil. So the bottle cap is floating on top of the oil. That means that the bottle cap is more dense than the alcohol, but not as dense as the oil. So it's less dense than the oil, so it floats there. The screw, I'm going to bet that it goes to the bottom. Let's check it out. It goes all the way straight to the bottom of the container. And you can see that right there. It goes straight to the bottom of the container. That kind of makes sense. What else do we have? And actually, it looks like the bottle cap descended a little bit farther. It was just really slow moving. It looks like it floats on top of the water. I have a red bean here. And drop the red bean in here. That goes through the water, and the red bean looks like it floats on top of the Karo syrup, at least for right now. So it went down through and it floats on top of the Karo syrup. What about a straw? Regular old straw, like a drinking straw. Looks like it goes through the alcohol layer, and at least for now, it looks like it is right on top of the oil. Anyway, you can have fun dropping various things in there. I have a paper clip here. Let's see where the paper clip goes. Paperclip shoots down, goes into the Karo syrup. Let's see if the paperclip stops on top of the honey or not. Let me turn that here like this. Looks like the paperclip might stop on top of the honey there. It just depends. Sometimes whenever it hits the really thick layers, it just takes time to settle through. So that is what we call a tower of density, or a density tower. Basically what we're doing is finding different liquids from around the house and choosing them and stacking them on top of each other so we can see the different layers, and that's telling us how dense each of these liquids basically are. The least density item, liquid's going to be at the top, and the most dense is going to be at the bottom. Once you've constructed your density tower, you can start dropping various things around the house. You know, make sure you choose things you don't mind if they get a little wet or a little sticky. And depending on how dense they are, that's where they're going to stop and start to float. So they'll go down to the level, to the liquid level where they begin to float. And it all depends on the relative density. I'm Jason with ScienceandMath.com. I hope you've enjoyed this experiment. It's very simple to do, very easy to find materials. Just need to make sure and get permission before you start mixing things together to make sure it's all safe, which this all is. And then you can go have fun learning about density, learning about buoyancy, and using the knowledge of science to predict how this sort of thing is going to work.